Good afternoon, class. Is my voice loud and clear, and is my shared screen visible?
Yes, ma'am.
Okay, thank you. If it breaks, if my voice breaks in between, just let me know, okay? So today we are going to start the chapter deadlock, as you can see in the whiteboard, okay? And this chapter is the last chapter of your syllabus for operating system for this semester. And in this particular chapter, deadlock, it's more of theoretical aspect with one algorithm that is there to solve the deadlock issue. That algorithm we will be studying with the help of a numerical. So if time permits, we will finish it today. If it doesn't, then we'll leave the numerical for the next lecture. Okay, so let's start with deadlock. If you have any queries from your previous lecture, let me know. If you have none and I can proceed, please write in the chat box, no doubt, so that I can proceed with today's lecture. If you have any, just post the query in the chat box or unmute your mic. Do you have any queries from your previous lecture, class? Okay, thank you, Subhash. So let's proceed. What is a deadlock? Okay, so deadlock is definitely a problem that only arises in a system with multiple active asynchronous processes. Okay, if we synchronize the processes, then there will not be any issue. And how to synchronize the process, that we have already studied in your process synchronization. Okay, so if there are processes that are asynchronous with one another and they are running in multiple devices, or if there are processes running to get the excess of unshared resources, then also it may end up in deadlock. Okay, so now it is important that the students learn the three basic approaches to deadlock. Okay, the three basic approaches to deadlock is your one is your deadlock prevention. Two, we must try to avoid deadlock avoidance, we call it. And the third is your deadlock detection. First of all, we must not let deadlock occur. Okay, we should not let deadlock occur, and that process is called as prevention. And if deadlock occurs, then how to avoid it is that handling mechanism is called as your deadlock avoidance. And if deadlock occurs, then it is first important that we detect that the deadlock has occurred. Okay, then that mechanism is called as your deadlock detection. So these are the three things that we will be studying in your deadlock chapter. Okay, so deadlock has some characteristics. Okay, so now if there is deadlock to be occur in a system, if we think that there may occur deadlock in a system, then there are some necessary conditions for deadlock to occur. Okay, then there's deadlock characterization. Deadlock characterization. So that means, what do I mean by this is, how do we know that deadlock will occur? Okay, so there are four necessary conditions that will say that deadlock will occur. And deadlock will occur in any system if all of these four conditions occurs simultaneously. That means, out of this four condition, if three condition occurs and one condition does not occur in that system, that means that there will be no deadlock in the system. For deadlock to occur, all these four conditions must occur simultaneously. Okay, the first is your mutual exclusion, and lots of questions are asked from this topic. Okay, first is your mutual exclusion. Second is your hold and wait. third is your no preemption. Fourth is your circular weight. That means a system. Okay, so when we talk about system, a deadlock is a problem which will end up our system being in hang mode. Okay, so that means we are in a lock, the system has been locked, and it's a dead end. We are not able to come out of that system. You cannot do anything to bring that system alive. Okay, bring that system into live mode again. So that means it's a lock and it's a deadlock. There is no key to that lock. When we have a key to a lock, then it will not be called a deadlock. Okay, so there is a problem and there is no solution to it, that is deadlock. So if we have some problem like that, then how do we handle it? Okay, first we have to make sure that deadlock never occurs. Then such type of solution is your deadlock prevention. And after deadlock occurs, how what do we do? Okay, your system has entered into deadlock, so now what do we do? Should we throw that system? Should we destroy that system? What do we do? That is your deadlock avoidance. But deadlock has occurred. First of all, we need to detect it, right? So that is your deadlock detection. So before we move into the providing solutions to your not solution, handling the deadlock, we need to know what are the necessary conditions that will lead the occurrence of deadlock in a system. Okay, the necessary, these four conditions are all deadlock characterization, also known as necessary conditions for deadlock. These are four necessary conditions. That means mutual exclusion is not there, hold and wait is there, no preemption is there, circular weight is there. And if all these four conditions occur simultaneously, that means that deadlock will surely occur. The system will end up into deadlock. Okay, so let's explain each one of these conditions. First of all, let's see how these four characterization and necessary condition will lead your system to deadlock. Okay, so what is your mutual exclusion? Okay, so first we'll go for mutual exclusion. Mutual exclusion is at least one resource must be held in a non-shareable mode. For example, your printer. Okay, so now if your network is connected, a network of computer is connected to one single printer, and let us say four people, 1 2 3 4, all of them want to print. Okay, so if number one is printing, then number two and number two, number three and number four is in deadlock. That means they cannot do anything right now because it is already in printing mode. Okay, so if we have at least one resource that is non-shareable, then deadlock will definitely occur. For example, your banking system. Okay, if you are making an online transaction, okay, if you are making a payment through your internet banking INB, then you cannot make at the same moment, you cannot make payment from your Google Pay, ATM, credit card, anything like that. Okay, because that's a form of resource which cannot be shared by other processes. That means mutual exclusion is there. It has to be, the resource has to be mutually excluded. That means when one process is in the critical section, other process cannot enter into critical section. If we have any form of this resource, if we have any for the network or the software or the application wherein there is at least one resource, then that cannot be shared, then that is mutual exclusion, and that meets one necessary condition for deadlock. So now mutual exclusion you have understood, right? So now if we have anything like this in that application area, then there now is a chance that deadlock will occur. But that if only mutual exclusion is there, that does not mean deadlock will definitely occur. For deadlock to definitely occur, we must have mutual exclusion, hold and wait, no preemption, circular weight. That means ये चारों के चारों एक ही साथ होना चाहिए, तब deadlock होगा. Okay, mutual exclusion is there is one non-shareable resource. Okay, and if it's so, then we have to have mutual exclusion. And if we have to meet mutual exclusion, then it may lead to deadlock. Okay. Now next is your hold and wait. Hold and wait. Let us say I have process P1, okay, and I have process P2. Let's say process P1 is executing. It needs scanner, it needs printer, and it needs a variable R. Okay. So now P2, okay, is also executing. P1 is also executing. Now it needs a resource C, D. Okay, and also it needs the resource printer now. And let's say I have only one copy of printer. So now what P1 is doing? P1 is holding resource S, resource P, and resource R. Okay. Now let us say to complete, for P1 to complete the task, okay, for P1 to complete the task, resource P1 needs D. Sorry, process P1 needs D, okay, to complete the task, and it is currently holding S, P and R. That means P1 के plus S है, P है और R है, इसको complete करने के लिए resource D चाहिए. Okay, so now similarly now I have process P2. Now process P2 has with it resource C and resource D. Okay, so let us say to complete its task, it needs resource A. Okay, now it is holding C and D, and it needs A to complete the task. It is not getting A. Now P1 is also running. It is holding with it. It has with it, and it is keeping hold of S, P, and R, and it needs D to complete the task. Okay, but it will not get D. Why? Because P2 has D, and it is not releasing D because it is waiting for A to complete its task. So we will enter into deadlock. Why? For P1 to complete, it needs D. Okay, so now D is with P, but for P2 to complete its task, it needs A, and A is being used by some other process. Okay, so what is it doing? P1 is holding resources and it is waiting. Okay, P1 is holding resource S, P and R, and it is waiting for resource D to complete the task. Now process P2 is holding resource C and D, and it is waiting for A to complete the task. So now comes the issue of hold and wait. Each process is holding certain resources and it is waiting for some other resource to complete its task. Okay, so it is called as your hold and wait. Now mutual exclusion, let us say there is at least one non-shareable resource, and also in a system hold and wait has occurred. Okay, so now third comes non-preemption. So what is non-preemption? Let's see. Now I took an example where P1 was holding resource, I think S, printer P, and resource R. Okay, so process P2 was holding resource, I think printer, let us say C, and it was waiting for some A, anything like that. Okay, so what is no preemption? No preemption is process P1 is holding this and is waiting for D. Okay, so it had D, right? It had D. Now P1 is holding S, P and R, and it is waiting for D. And P2 has resource P and D, it is waiting for A. So neither P1 is preempting any of the resource. So let us say if P2 had agreed to preempt this resource D, that means if P2 had released resource D, then P1 would have completed its task, would have completed the execution. Okay, but P2 is not preempting this resource. Okay, and because P1 is not preempting this resource, P1 is unable to complete the execution. Same is with P2. It wants A is with someone else, So P2 is also not able to complete the task because none of the process is ready to preempt. That means the operating system follows non-preemption of the resource technique. Okay, so that means I have one non-shareable resource now. Second, processes are holding and waiting for resource. Third, processes are not ready to let go of the resources because it's not completing its task. Okay, so I'm not able to complete my task. I will release my resources so that somebody else will complete the task. No, no, none of the processes has that big heart. Okay, so now we do not have no preemption. Okay, so we do not have preemption. So everyone is holding and waiting, and none of them are releasing the resources. Okay, so that is called as your no preemption. Now, fourth is your circular wait. Circular wait is this one. Circular wait is, let us say now I have process P3. Okay, so process P3 has the resources, let us say E, F, and it needs resource S to complete, and it also has, let us say, resource A. Let us say it has resource A, okay, and it needs resource S to complete. Okay, so now see here, what is the problem here? The problem is P1 has resource S, P, okay, and R. It is waiting for D. Now D is with P2. It is holding and waiting. Okay, so now P2 has P and D, but it is waiting for resource A to complete. But now resource A is with process P3. So now P3 has resource E and F. Okay, EFA. For P3 to complete its task, it needs resource S. But now resource S is with P1. Now see, P1 to complete it needs D. D is with P2. P2 to complete it needs A. A is with P3. P3 to complete it needs S. S is with P1. So P1 is waiting for the resource that is with P2. P2 is waiting for the resource that is with P3. And P3 is waiting for the resource that is with P1. That means we have created a circular wait. Okay, this is waiting for this one is waiting for this one, and this one is waiting for this one. The final is waiting for the starting point. So we have created a circular wait. So now we cannot break this chain because each one of this process is waiting for another process to complete its task. This is called as your circular wait. Now, if all of this mutual exclusion is there, hold and wait is there, no preemption is there, and circular wait is there, then definitely deadlock will occur. Now we have circular wait, and because there is a circular wait, none of the process is ready to preempt. That means nobody is releasing any resource, so no preemption is there, and everybody is holding. Everybody P1 is holding and waiting for D. P2 is holding PD and waiting for A. And also there is mutual exclusion. So this is the printer P. Okay, let us say it is non-shareable. It cannot be shared with others, but other process also needs it. But now it cannot be shared. So now this system will enter into deadlock. Okay, because all these four conditions has now occurred. Okay, so now is deadlock clear, and is the necessary condition or deadlock characteristics clear? If clear, write in the chat box clear, then I'll proceed with another topic. If not, write down which topic is not clear, I'll explain again. Ma'am. Okay, Subhash, let's understand, hold and wait for once more. Let us go with the meaning of English meaning of hold and wait first. Okay, what is the meaning of hold in English? In English, hold means किसी चीज को अपने पास रखना. Okay, किसी चीज को अपने पास रखना, टू होल्ड इट. ओके, एंड नॉट लेटिंग गो ऑफ इट. अपने पास रखना, इसको जाने मत देना, इज होल्ड. वेट मीन्स इंतजार करना. ओके, सो नाउ लेट अस से I have process P1. Okay, so it needs printer P to complete its task. It needs scanner S to complete its task, and it needs a CPU. Okay, so now there is process P2. Let us say your laptop has two processes, that means two CPU. Okay, your P2 needs CPU. Okay, your printer P2 also needs, let us say, printer, and it needs some other files F. Okay, so I have two CPU, but let us say I have only one printer. Okay, so now if you see here, I have process P1. Okay, for process P1 to complete its task, it needs printer, it needs scanner, and it needs CPU. So let us say P1 has entered the ready queue first, so it gets all of these three. Okay, all of these three, so it is in execution now. So now process P2 enters. Now it, because there are two CPU, so it has one CPU, so it will get another CPU. Okay, so now process P2 needs a printer, but I have only one printer. One printer is taken by P1, so I do not have any printer right now. So now P2, what will it do? It will now wait. It will wait for P1 to complete. Okay, so let us say process P1 is such type of process which executes for 2 hours, 3 hours, or 10 hours, like that. Okay, it's, let us say it's a SBI banking function wherein the function or the method is sending monthly statement. So it may take 24 hours. Okay, so for process P2 to complete its task, some timing is given. So let us say process P2's waiting time, the overall execution time, it can take only 5 minutes. So it is running for 24 minutes. So it will enter into deadlock now. Why? Because process P1 is holding these resources. Okay, and let us say now there is resource E. There is a resource E. Okay, so process P1 is holding. Process P1 has with us P, S, and CPU. Okay, printer, scanner, and CPU. But to complete it, it has been executing. But for P1 to complete its task, it is now waiting for resource E. Okay. To complete its task, now let us say P1 is waiting. P1 has been executing for some time, and to complete its task now it needs resource E. So it has holded. It has with it these many resources. So it has it. Has it means hold. It have them. Okay. So now it is waiting for resource E. So now let us say now resource E is with P2. Resource E is with P2, and now P2 has started its execution. Let us say, okay, it has started its execution. To complete its task, it needs resource F. So it has now, it holds, it will keep with it because it has not completed its task. It is waiting for F. जब ये इसके लिए wait कर रहा है, it is not releasing this. Okay, so if you remember during our childhood, or you might have heard about that story where there are two siblings, two small siblings, a boy and a girl. Both of them have to go to a faraway school. Okay, there are two siblings. It's a boy. One is the boy and another is the girl. Okay, both of them have to go to a faraway school, and they have only a pair of shoes. Okay, both of them have only one pair of shoes to wear and go to the school. So what happens is the boy goes to a morning school and the girl goes to a evening school. So for girl to go to the evening school, it waits for her brother to come back from the school so that she can wear the pair of shoe. Okay, so that thing was going smoothly. She goes halfway, she waits for her brother, and while on his way back, he gives that shoe to his sister, and the sister wears the shoe and goes to the school. Okay, but one fine day, for some reason, boy gets the punishment and he's held back in the school. So when he is held back, okay, that resource, a pair of shoe, is also held by that boy, and because of that reason, now girl cannot complete its task, cannot go to the school, because now girl needs that shoe to go to the school, but that shoe is with somebody else, is in hold with somebody else. So that is called as your hold and wait. So if we have hold and wait, deadlock may occur. With each of them, it may occur. If mutual exclusion, deadlock may occur. Hold and wait, deadlock may occur. But all four of them, deadlock will occur. Okay. So now, Subhash, is hold and wait clear now?
Yes, ma'am.
Okay, so now let's move to the next topic now. Okay, so the next topic of the day is your resource allocation graph. Okay, resource allocation graph is a type of graph that is used to see if it is used to keep record of how many resources are there. Okay, how many copies of each resources are there. For example, if I have printer P, scanner S, keyboard K, a file F, okay, and how many copies of files I have? Two, let us say printer 2, scanner 1, keyboard 2. Okay, so resource allocation graph is first keeping a stock of how many copies of resources are there. 2, mapping these resources to the respective process who has the hold of the resource. So if I have process P1 and it has one copy of file, one copy of printer, and one copy of scanner, so it will keep the stock of P1, F, P, and S. So if now I have process P2, okay, so let us say this one, and this one. So now if process P3 comes and it requests for F, no, we cannot have, because it is one cardinality here, one cardinality. So now the remaining file is 0. So P3 cannot have it now. Okay, so that is your resource allocation graph. How many resources are there and to which process the resource is allocated. And the graph used to keep the track of, or the graph that is drawn to allocate resources to the process is called as your resource allocation graph. And in the resource allocation graph, if and it is a directed graph means like this, a direction is given. So if the resource allocation graph, okay, has a circle or a cycle in it, that means a deadlock may occur. Okay, so it can also be used to detect if a system can enter into deadlock or not. So we use resource allocation graph, and it has three purposes: to keep the stock of the resources, to allocate resources to the processes, and to see or to detect if deadlock can occur. And we can say a deadlock may occur if there is a cycle in the graph. Okay, so let us take an example. Let us say I have process P1, process set of P, sorry, let us say I have a set of process P. Okay, I have three processes, P1, P2, and P3 submitted for execution. Okay, so now I have resource R. Let us say I have resource R1, I have resource R2, I have resource R3, I have resource R4. Okay, so now let me say that I have one copy of resource R1, I have two copies of resource R2, I have one copy of resource R3, and I have three copy of resource R4. Okay, so three processes have entered into the memory. Now they want to execute, and I have these many resources in my system, four resources, R1, R2, R3, R4. I have one, let us say if this is CPU, I have one CPU. Let us say if it is printer, I have two printers. If it is scanner, I have one scanner. And if I have a file, let us say I can create three copies of that file maximum. Okay, so these are the stock of the resources. So how do I draw a graph? Okay, so I draw a graph, let us by using annotations. Okay, so annotation is for process. Okay, for process I use circle. Okay, for process I use circle. For resources I use a rectangle. Okay, I use a rectangle, and for copies of the instances I use dots. If I have three instances, that means I will draw three dots inside of this rectangle. Okay, and now for association or for links, association or link, whatever you would like to call, I use, because it's a directed graph, I use an arrow with an arrowhead. Okay, so now if I have process P1, okay, if you are given, let us say I have process P1, I'm given process P1, P2, P3. So I draw process P1, process P2, and process P3. Okay, so now I have been given, I have four resources, resource 1, resource 2, resource 3, and resource 4. Okay, so let me draw resource R1, and I am being given that resource 1 has only one copy. So I have been given resource R2, and I have two copies of resource R2. I have been given R3, and I have only one copy of resource R3. Okay, now I have been given R4, and I have three copies of R4. So now, okay, process states that process P1 is holding an instance of resource R2. Okay, that means process P1 के पास अगर R2 है, then we'll start the arrow from R2 के इस instance को touch करते हुए, we will end that arrow by touching the boundary of the P1. So this means P1 is holding R2. That means P1 has resource R2. Now for P1 to complete its task, it is waiting for R1, let us say. Okay, so I will draw a diagram from P1. If it is waiting, I will draw from here. Okay, I'll draw, give the direction like this. If it is, the arrowhead is touching the process P1, if arrowhead here is touching P1, that means it has it. That means P1 has R2. But P1, this association or link does not has this arrowhead touching here. Okay, so that means it does not has R1. So because it is going away from P1, that means it is waiting for R1. Resource R1, it is waiting. Okay. So let's try one more. Let's say P2 is holding instance of R1. Okay, P2 has R1. So see here, P2 is a touch kiya, that means P2 has resource R1. Okay, so let's say now P2 for P2, let us say P2 also has this one R2. Okay, so P2 is holding R1, and later also there P2 is also holding R2. That means P2 has two resources, R1 and R2. So now let us say P2 is waiting for now R3. Okay, so now let's end this diagram here now. So that means I have three processes. I have three processes, 1, 2 and 3. I want to detect deadlock. So to detect deadlock, I am using resource allocation graph. For deadlock detection, a resource allocation graph is a directed graph. It is used for, I've already said, deadlock detection, keeping the record of resources, allocating resources to different processes, etc. Okay, so now I have three resource processes. Now process P1, when it submitted, it said that I need R1, R2 and R3. Okay, so when it said that, it had R2 was given. Okay, so P1 to P1 R2 was given, but it is now waiting for R1. Now P2 to complete its task, it needs R1, R3 and R2. Okay, so now P2 has R1, P2 has R2 because the arrowhead is towards P2. But now it is waiting for R3. Okay, so now P3 is a type of process which does not need any of these resources. Let's say it just needs a compiler, it wants to compile and it is done. Okay, and same, I have three copies of resources. Let us say I have three printers. Now none of the process needs the printer, so it has kept a record of this one, but currently running processes does not need these resources, so it is just kept like that. Okay, for record purpose. So now how do I detect deadlock? So I check, have I created any form, or has this process has created any circular, has created any circle here. P1 to R1 I'm going, R1 to P2 I'm going. Am I going from P2 to R2? No. Okay, if the arrow was like this, then there was a circle and the system may have ended into deadlock. Okay, but the arrowhead is not like this, the arrowhead is like this. I have not created a circle. That means if I will make these processes execute, then my system will not enter into deadlock. Okay, so this is how a resource allocation graph is drawn. These are the different notations, and this is the purpose definition of your resource allocation graph. Is it clear? Is it clear? Thank you, Rashmi. Thank you, Rijwana. Thank you, Subhash. Thank you, Shivam. Okay, thank you. Okay, so now in exam or in competitive exam, they may give you this resource allocation graph, and you may be asked, they may not use the annotation P, P, P. They will use circle, rectangle, dots like this, but instead of P1, let us say they might just use 1, 2 and 3. So they may ask you, and here also 1, 3, 2, 4. So they may ask you how many processes are there. So circle means process counted. Resource means, if you are asked how many types of resources are there, so how many rectangles are there? 4. So 4, answer is 4. Okay, so if they'll ask for resource 4, okay, for resource 4, how many copies are there? 3. You'll write 3. You will write 3 because there are 3 copies of resources. Okay, so if you are given this graph, okay, if you are given this graph and then you are asked, in the given system, are there chances of deadlock? You will write down no. Why? Because there is no circle here. Okay, direction. So if you are asked, can deadlock occur in this system? If the answer is yes, okay, so let me alter. Let me now alter the directions here. So if this direction is like this, okay, then I have here I've created a circle of weight, circular weight. Okay, so if you're asked, can deadlock occur here, and if your option is 1 yes, 2 no, 3 maybe, 3 maybe, and 4 none or anything like that, okay, then your answer should not be yes. A circular weight here does not say or does not guarantee deadlock will occur. If a circle is created here, that means deadlock may occur. Okay, so your answer should not be yes. Your answer should be maybe deadlock will occur. Okay, another statements will be given. Okay, for example, process P1 is holding an instance. Process P1 is holding an instance of resource type R2, and it is waiting for resource type R1. Process P3 is holding resources R1 and R2. It is waiting for R3. Process P3 के लिए कुछ दिया ही नहीं. Okay, and then different diagrams are there. So different resource allocation graph diagrams are there. You may be asked to choose which one resembles the given statements. You have to select this one. Okay, so it may come in different forms. You'll have to practice different questions. Okay, so let's move to the next topic of methods of handling deadlock. Deadlock handling methods. So how should we handle deadlock? Now deadlock has occurred, let us say. Okay, so how do we handle deadlock? Principally, we can deal with deadlock problems in one of three ways. Okay, we can handle deadlock in one of three ways. Okay, so what we can do is we can use a protocol to prevent or avoid deadlock from happening and ensuring that the system will never enter a deadlock. Okay, we can prevent deadlock from happening, we can avoid deadlock from happening, and we ensure okay now deadlock will not occur. Why? Because we have prevented it, also we have avoided it. Okay, or two, we behave in a way that our system has been designed in such a way that it will never enter into deadlock. Okay, second, you be sure that deadlock does not occurs in your system. Okay, the third is you stay cool that deadlock will not occur, and if deadlock will occur, you leave up to the system. आप कंप्यूटर पे छोड़ दो कि वो कैसे हैंडल करता है. Okay, it is like you can ignore the problem altogether. The deadlock will never occur, and that is the solution opted by most of the system like Unix, Windows, and all. If your system gets hanged, then your operating system does not handles it, right? You have to turn off your computer, or you cut the power of your computer, you take out the battery of your laptop, something like that. Okay, so it is like you are ignoring the problem. Okay, second is you design the system in such a way that deadlock will not occur. And the first way is you design a protocol. Okay, you design your system in such a way that it handles three things. Okay, so what are these three things that I'm going to teach you now? Okay, so the deadlock handling methods 1, 2, 3. तो हम 1 को डिस्कस करें. 2 में तो यू डिजाइन योर सिस्टम कि आएगा ही नहीं, आएगा इग्नोर इट. ओके, सो फर्स्ट में we are going towards developing protocols. Okay, we'll develop protocols keeping in mind three things. What are that? Let's discuss that. So now we have said that deadlock will occur. Okay, for deadlock to occur, there are 4 necessary conditions. I've said that for deadlock to occur, there are 4 necessary conditions. That is mutual exclusion, hold and wait, no preemption, and your circular wait. If all these 4 conditions occur simultaneously, then deadlock will also definitely occur. Okay, so what we can do in handling deadlock is we can go for deadlock prevention. Okay, so we can go for to handle the deadlock. We can prevent deadlock from occurring. Okay, so how do we do that? We can do deadlock prevention. Okay, so how do we prevent deadlock? We prevent deadlock by avoiding mutual exclusion, by handling hold and wait, by handling no preemption, and by handling circular wait. So if we make sure, if we will make sure that at least one of these conditions does not occur in any system, because for deadlock to occur, I made it clear that all four of these must occur simultaneously. अगर डेडलॉक होने के लिए ये चारों को एक साथ होना पड़ेगा, then we can prevent deadlock from occurring by handling, making sure कि one of these never occur. हम ये मेक श्योर कर सकते थे है कि हमारा सिस्टम में ये एटलीस्ट इनमें से चार में से एक तो कभी नहीं होगा. Okay, that way we can prevent deadlock from happening. Okay, so let's start with mutual exclusion. Okay, because mutual exclusion is very critical aspect of anything. If it's a banking system, then mutual exclusion has to be there. It has to be there in banking system. Okay, because a banking system is a critical section problem, and if we want to handle critical section problem, if you remember critical section problem, then how did we handle critical section problem? We handle critical section problem by making 100% sure that mutual exclusion is there. So to avoid deadlock, if we will remove mutual exclusion, then critical section problem will be at loss. So we cannot manipulate mutual exclusion. So that means to prevent deadlock from happening, we cannot manipulate mutual exclusion. Okay, so हम इसको touch नहीं करते. So to prevent deadlock from happening, we cannot make sure that mutual exclusion will not occur. Because if we make sure mutual exclusion does not occur, that means we are not solving critical section problem. Okay, so we do not touch it. So there is no scope of making sure mutual exclusion does not occur. There is no scope for it. So let's try to prevent hold and wait from occurring. Okay, so let's see how. So you design your protocol in a way that hold and wait does not occur. So how can we make sure of that? We can make sure of that by, let us say, P1 has resource A, B, and it is waiting for C. So now P2 has D, B, it is waiting for F. Okay, so it has holded and it is waiting for C. It has hold of D and B, it is waiting for F. So how can we design our protocol? Our protocol is, if P1 is waiting for C for, let us say, 2 seconds of time, and it has not got C so far, then we can force P1 to release this. Okay, so that means when a process enters into waiting state, make them enter into waiting state only if they will release the resources that they have. In this case, let us say for PT to complete, it needed, let us say for PT to complete, it needed C. Okay, P2 needed C. So the moment P1 enters into waiting state, it has released AB, sorry, okay, it needed, let us say, A. So for P1, it wanted to enter into waiting state. So to enter into waiting state, we have designed our protocol wherein it has to release A and B. So now P2 is executing in the CPU because P1 has released A. Now P2 will complete its task. So let us say P2, actually P1 was waiting for D. So now because P2 has got now A, so it has completed its task. Now it will release D क्योंकि इसने terminate हो गया. So now P1 from waiting state, it can enter into running state because it has now D. Okay, and it will also complete its task. So how can we prevent deadlock from occurring? By making sure hold and wait does not occur. How do we make sure of that? We make sure of that by making sure when a process enters into waiting state, it will release all the resources that it has. Okay, so that is your manipulating, holding and wait to make sure deadlock is prevented. Okay, so now let's talk about no preemption. So no preemption is when your processes does not preempt the resources. So here also solution is simple. If process P1 has A, B, okay, has A, B, and it is waiting again for C. Okay, it is waiting again for C. So no preemption is again simple. If it is waiting for C, tell P1 to preempt or release A and B and then enter into waiting state. Preempt the resources. Okay, so we are making sure, or we can prevent deadlock from occurring by making sure preemption is there. Okay, we make sure the processes follow preemption instead of no preemption with respect to the resources. That is, if a process is holding some resources and request for another resource that cannot be immediately allocated to it, then all resources currently being held are preempted. उसको छोड़ना ही पड़ेगा. So if we make sure hold and wait is not there, then also deadlock will not occur. Or if you cannot do that, and if you force your system ki no, preemption is there, then also deadlock will not occur. Okay, so now fourth is your circular wait. Okay, fourth is your circular wait. Circular wait I have already explained. The fourth and your final condition for deadlock is the circular wait condition. One way to ensure that this condition never holds is to impose a total ordering of all resource types. That is, if I have process P1, okay, if I have process P1, it has resource R1. Okay, so now if it wants resource R2, okay, let us say I have a resource R1 and it needs another copy of resource R1, then it has to be R1 जो इसके पास है. And if it is requesting for another resource, actually what the circular wait says is replace each resource with some numerals. Let us say I have R1, R2, R3, R3. Okay, so circular wait says don't give names to the resource, assign numbers to it, 1, 2, 3, like this. Okay, and then it says now because number is given, and if a process P1 comes, okay, and it needs its resources, let us say, so now it has resource 1, now it resource R2, so it has to compare, it can request only for that resource if your R1, if your this number N1 is lesser than your N2. Okay, so that means if it already has 1 and if it wants 2 or 3, now 1 is lesser than 2 or 3, then only assign 2 and 3 to them. So now if it has resource 2 and it is waiting for resource R1 and you have assigned number 1 to R1, don't, and now your 1 is smaller than 2, so the condition here is not fulfilled. Okay, so don't assign them resources immediately. Okay, because now this number is smaller, it believes that it may create a circular wait. It believes that it may create, because it's smaller now, it may create a circular wait. So now to avoid it, if the number assigned to that resource is smaller than the currently held resources, don't assign them, wait for certain time. Okay, you have to assign the timing, wait for that time, and until that time, if resource request is not for that time, it will enter into waiting. Okay, so somebody else, whomsoever has it, will release it. After it releases it, when it goes to the running state, then again start assigning from smaller number to the bigger number, just to break the circular chain. Okay, so here it says assign numerals to its resources, and when a resource is requested, the requested resource Rj must be greater than the currently assigned resource Ri. If it is not small, make it enter into waiting state. Okay, and then it should be assigned. When it comes to the running state, it must be assigned the resources in incremental order. That means first it must be assigned smaller, and then it must be assigned bigger, and then bigger, like that. Okay, so this is a way, this is the protocol that can be proposed to prevent the deadlock from happening. So is deadlock prevention clear to you all?
Yes, ma'am.
Thank you, Subhash. Others, is deadlock prevention clear? Other than Subhash, is deadlock prevention clear? Circular it, okay. Circular wait first says that whatever resources you have, let us say you have process, you have scanner, you have printer, you have keyboard, etc. Okay, so what is circular wait? Something like this. Process P is waiting for P. Now somebody for process P1 to let us say process P1 is waiting for S to complete its task, which is with P2. P2 is waiting for P, process P, which is with P3. P3 is waiting for K. Is with P4. Now for P4 to complete, it is waiting for printer again. Something like this. This is creating circular wait. Okay, so we make sure circular wait is not there to prevent deadlock from happening. So how do we do that? We do that by, first step is, for each resources you assign numbers. Don't use the name of the resource, you assign number to it. Okay, so now if process P1 comes, okay, when process P1 comes, so now if it wants resources, okay, so if it is requesting, if it is the firstly submitted process, and it wants process CPU, let us say printer, scanner, what was it, printer, scanner, क्या था? Process, okay, printer, process, scanner and processor it wants. Okay, so assign them in incremental, because now these resources are saved as 1 2 3 4. They have been given some id numbers. Okay, 1 2 3 4. If it is a firstly submitted processor, then assign them resources in 1 2 3. Okay, so let us say it needs all of them. So 1 2 3 4. So let us say now when P2 comes, let us say a new process P2 comes. Now it is not a newly submitted process like this. Let us say it is a old process. Okay, old process. Now it already has, let us say, resource 3. Now it is waiting, asking for resource 1. So now what does it says? This circular wait says is, if it is requesting for resource Ri, sorry, Ri, now it is requesting for this one. If it is requesting for R1, check whatever resource it has, okay, and compare if the the resource that it has currently is smaller than the requested resource or not. Let us say Rj. Let us say Ri is your 3, Rj is your this one. So now is 3 smaller than your 1? No. Okay, 3 is not smaller than your 1. So in such case, circular wait says don't assign. Give me 1 minute. I need to plug in. My battery is down. circular weight says that because now Ri is smaller than Rj, don't assign resources. Okay, so don't assign resources. So what it does is now P, which is equivalent, which is been given the ID1, will not be given to it. So now P2 will now enter into waiting state. So when it enters into waiting state, you do preemption of this one. So it will release all the resources. So now we know that it needs 1 and 3. So next time when it enters into running state, then only give it 1 and 3. So assign the resources in incremental order. Okay, so we, what happens is it क्या solution हो रहा है? The solution that it brings is, if we are assigning it in incremental order, then we know that if I have process P1 and if I have 4 resources 1 2 3 4 and if it has resource 3, that means that it can only be assigned resource 4. If it will be if it will request 1 and 2, then operating system will make it enter into the waiting state. Okay, so हम क्या कर रहे हैं, हम आगे तो जा पा रहे हैं. With this approach, we are able to move upward or go forward. Like from 3 we can go to 4, but from 3 we cannot go back to 1 and 2. Okay, we can go to 4 from 3, but we are not allowing the decremental order. Then if we are allowing move forward but we are not allowing go backward, that means we are breaking the chain of circular weight. Okay, so that is your circular weight. Allow the assigning of resource. First, to each resource assign some numerals. Second, when a process requests for resource, if it does not has it, assign them the resources in incremental order. Problem solved. But if they already have some resource like this P1, it had 3. So if it had requested 4, assign them because it is bigger. Now Rj is greater than Ri, assign them. Now if it is requesting for 1, now your Rj is not greater than Ri. It is not greater than, because now it is requesting for 1. It is not greater. Okay, then don't assign them. If it is smaller, put them in waiting state. So हम forward allow कर रहे हैं, backward allow नहीं कर रहे हैं. That means if there is no backward, only forward, then there will never be a circle created. There only be a line. So this way we can prevent deadlock from happening if we make sure one of these never holds. Okay, so Ram, is circular weight clear now? Okay, so now we will go for another topic, deadlock avoidance. Okay, so now for handling deadlock handling methods, there are 3. Okay, so out of 3, the first protocol that provides deadlock prevention mechanism. Other 2 have already 2 and 3 already discussed. From out of the first one proposes deadlock prevention. Deadlock prevention brings 4 types of algorithm that you can come up with. Your algorithm program is such that it will make sure hold and wait never occurs. Then one of the necessary condition is broken, so deadlock will never occur. Okay, we cannot manipulate mutual exclusion because of critical section problem, so you can manipulate these 3. Okay, so now next is your deadlock avoidance. Okay, so now you can avoid deadlock in one of 2 ways. Okay, avoid deadlock in one of 2 ways. One, you can use resource allocation graph. Okay, if there is circular weight, don't make the execution of that process. If the execution of that newly submitted process creates a circular weight, then do not let that process execute. Okay, that you can make sure by resource allocation graph. I've already explained this. Okay, Second is use any algorithm. Okay, use an algorithm to avoid deadlock from occurring. Okay, so for deadlock avoidance, the algorithm that we are going to study is Banker's algorithm. Now, because this Banker's algorithm needs a problem to be solved, एक numerical solve करना पड़ेगा. So I'm keeping it as the last topic. Okay, so under deadlock avoidance, I've already taught you this. There is an algorithm. That algorithm I'll explain with the help of numerical, जो हम इस chapter के आखिरी में करेंगे ताकि वो आपको अच्छे से clear हो जाए. Okay, so now we are moving to the next topic. How do we recover from deadlock? Okay, so now we tried to prevent deadlock, it did not work. Okay, so we tried to avoid deadlock, we could not avoid it. So now deadlock has occurred. अब deadlock हो गया है. So how to recover from deadlock? Okay, how do we recover from it? So that is what we are going to study now. When a detection algorithm determines that a deadlock exists, several alternatives exist. Okay, one possibility is you inform the operator or the administrator that a deadlock has occurred. Like bank में अगर हो गया तो whomsoever is the network administrator, you can inform them and they will handle it manually. They will do whatever is needful or possible to do manually, like turn off your computer, restart it. Like you must have watched Mangalyaan. Okay, a deadlock occurred, so the system is somewhere else, they are in earth, they cannot do anything, so they did a manual approach, shut down the system, turn on it again. Okay, so that is your manual approach. You can inform the administrator, they can take some deadlock to come or to recover from the deadlock, they can do some manual approach. Okay, or other is break the chain of the deadlock. If I make sure that you can make sure that hold and wait does not occur, circular wait does not occur, or make sure or force a process to preempt. Your process is running currently, so you force it. For instead of shutting down your computer, let us say you have opened browser, word file, notepad. Okay, so your Google Chrome is not responding. At the top you can see not responding, so you want to go to the word file from the browser, you're not able to go, so your system enters into deadlock. So you have three processes running: calculator, Google Chrome, and your word file. So you have two options: turn off your computer. Second option, you kill one process. So you force your Google Chrome, close Google Chrome, force or stop it from वो करके आता है stop wait करके. So you force the Google Chrome to close. So that means you're forcing a process to terminate. Okay, so you can do something like this to recover from the deadlock. Okay, so the first technique to recover from the deadlock is process termination. Process termination. Okay, so what you can do in process termination is, what all you can do in process termination is, you can abort all deadlocked processes. You can kill processes. आप जितने भी processes है अभी सबको kill कर दो. You kill all the processes. Okay. Second is just abort one process at a time. Sometimes what happens is, if you have opened three processes, instead of just Google Chrome, all the process stops working. Like calculator doesn't work, your word file doesn't work, your Google Chrome does not work. Whatever you open, just it keeps opening, but it doesn't gets closed. So one solution is you close all the process. Okay, but if you have written something important in your Word file, you have not saved it yet, and your system enters into deadlock situation. So next thing you can do is you can start terminating process one by one to see if you can save at least one. For example, if right now Word is important, so you first close your Chrome, and then you, after you successfully close it, if your system comes out of deadlock, then good. If not, then you again close calculator, like that. Instead of closing all at once, you can choose to close one by one. Okay, but in this case, what are we doing? In this case, we have to select a victim. Okay, you'll have to select a who is going to be that process that will be closed first. Select a victim. So selecting a victim poses a series of questionnaire. Okay, it has a series of questionnaire. For example, what is the priority of that process? On what basis will you close that process? How long the process has computed and how much longer the process will compute. For example, if you have a process that has been running for 1 hour and needs only 5 minutes to complete its task, and there is another process that has just started execution 5 minutes back and has needs 1 hour more, so obviously in this case you can prioritize to close that second one, because एक को complete करने के लिए 5 मिनट चाहिए, दूसरे को complete करने के लिए 1 घंटा चाहिए. Okay, so you have various factors that will that you can say like various factors, many factors that can be choose to select a victim. Okay, to select a victim. So abort one process at a time is one solution. So to do that, you have to select a victim. There are a series of questionnaire you must ask, and that are based upon many factors. Okay, so the second thing that you can do is resource preemption. Resource preemption. Okay. Now, to eliminate deadlock using resource preemption, we successfully preempt some resources from processes and give this resource to other processes until the deadlock cycle is broken. Okay, किसी और को दे दो so that it can finish its task until you can break the preemption. Again, from which resource you will snatch, from which process you will snatch their resources. Again, you will have to select a victim. बहुत सारे प्रोसेसेस है, किससे अपना रिसोर्स छीनोगे. Okay, so you'll have to select a victim. Which resources and which processes are to be preempted. Okay, so the other ways, if you do not want to snatch something from any of the resources, what you can do is you can just roll back. That means you can, if we preempt a resource from a process, what should be done with that process? Okay, like for example, let us say there is process P1. From there you have process P1 has printer P. Now there are P2 and P3, both of them needs the printer. So now to whom will you give that printer? Okay, that also has to be decided. And also you can, instead of doing that, you can start the process from the starting again. उसको फिर से roll back करके start से तुम उसको start करने के लिए बोल सकते हो. Okay, roll back from the starting. Another is you have to make sure. Okay, so when you do the preemption, there is an issue. Okay, the issue is of starvation. The issue is starvation, that is how to make sure that starvation will not occur, because every time you preempt, let us say process P1, your system is not entering into deadlock. Every time you start P1, the system enters into deadlock. In that way, process P1 will enter into starvation. So while selecting a victim, you have to make sure you don't select that same victim every time, because if you select that same process as a victim every time, your system will enter into starvation. Okay, so these are the various ways. Okay, these are the various ways to make sure your system recovers from deadlock. Okay, so is it clear? class, is it clear? Is deadlock recovery clear? For this, you can go for process termination. You can go for resource. There are two ways. Okay, sorry, actually this is not under. एक छोटा सा mistake हो गया. This is not under. This is one and this is two. Okay, one is you can do process termination, another is you can do resource preemption. Under process termination, you can abort all the deadlock process or choose one process at a time. Okay, second, in resource preemption, you select a victim or you roll back, but in both the cases you have to make sure starvation does not occur. Everyone is okay. Thank you everyone. So class, now I have only one topic left. Okay, class, now I have only one topic left, that is your banker's algorithm. Now banker's algorithm will take, I think, 5 or 7 minutes of explanation and 15 minutes of solving the problem. In overall, that means I need 20 to 30 minutes to finish your syllabus. There is only one topic left, that is your banker's algorithm under your deadlock avoidance. So now you tell me, if I cover this topic today, the syllabus of your operating system is finished. ओके, ऑपरेटिंग सिस्टम का आपका सिलेबस आज खत्म हो जाएगा अगर मैंने ये एक टॉपिक आज पढ़ाया तो. बट आई विल टीच ओनली इफ यू हैव द कैपेबिलिटी to learn that topic. So you guys tell me now, can I proceed and teach that topic, finish the syllabus, or you cannot, we should stop for today and whatever topic is left, we should study that tomorrow. What should we do now? Okay, Rijwana is saying we should stop for today. Others? Okay. So one more, please. दो जन ने stop बोला, at least एक जन बोलो, at least I need 3 stop. Okay, I will stop for today. Then we'll one topic is left, and that's numerical. So tomorrow again, before we start the class, you please be ready with a pen and a paper. Okay. So before you leave, give me some minute. I need to see if your attendance is recorded. Okay, class. So we have one last topic left now, and today is at 8th, right? So on coming Monday, that is on 12th, I'll take your third sessional. Okay, operating system ka third sessional will be conducted on 12th of July. That is your coming Monday. Okay. Prakash, are you there? Prakash. No, IGKLMN. Okay, so Prakash is not there. I'll inform him. So class, please inform your friends that on coming Monday you'll have your sessional for your theory. Okay, and you will have your लैब एग्जाम ऑन हमारा 2 घंटे का कब है, ट्यूसडे। ओके, सो 13th लैब का सेशन आपका कराएंगे हम on 13th. Yes, on 13th you'll have your lab sessional, and on 12th you'll have your theory exam. Okay, Krishna, we have exam on Monday. Krishna, what exam do you have? Krishna, what exam do you have on Monday?
Math
Ma'am,
exam, ma'am.
What? Koa. Okay. Okay. Koa and maths. दोनों Monday है?
yes, ma'am.
Okay, then. Okay, then we'll do one thing. संडे को दे सकते हो? संडे को 1 घंटा? Because I have to conduct lab exams as well. संडे को तो आप लोगों को भी फ्री अच्छा लगता होगा. Okay, then we'll do one thing. Tuesday we will take lab exam. नहीं, लैब का प्रोग्राम्स आपने कंप्लीट किया? Have you completed the lab programs? All you'll have to submit. Yes, okay. You'll रश्मि आपको वो भी कंप्लीट करना पड़ेगा, ठीक है? मेमोरी मैनेजमेंट में से 6 के 6 एल्गोरिदम, फर्स्ट इन बेस्ट, वर्स्ट एंड फर्स्ट फिट, एंड पेज रिप्लेसमेंट में से ऑप्टिमल पेज रिप्लेसमेंट, फर्स्ट इन फर्स्ट आउट, एंड योर लिस्ट रिसेंटली यूज्ड, ये भी कंप्लीट करने पड़ेंगे, ठीक है? Okay, then we'll do one thing then. On Tuesday, that is the 13th, you'll have your lab exam, and on 14th you'll have your theory exam. Okay. और एक और चीज बताना था, हाँ, for lab exam you'll have to submit your e-copy of your lab file. मतलब आपको लिख के नहीं, PDF में से as instructed on day 1. First page should be the front page wherein you'll have the logo university, जैसे फाइल होता है एक लैब का, आगे यूनिवर्सिटी का लोगो होता है, डिपार्टमेंट ऑफ कंप्यूटर एप्लीकेशन सिक्किम यूनिवर्सिटी सबमिटेड फॉर द पार्शियल फुलफिलमेंट ऑफ MCA करके दैट. Second page should be your certificate. Certificate should be the exact copy of university में जो फाइल का सर्टिफिकेट है. For that you can refer your seniors or you can refer your last semester में अगर आपने सबमिट किया होगा ढंग का सर्टिफिकेट, then you can refer that. If not, you can ask your seniors for a copy, okay, and design it exactly like that. Third page should be the index, okay, then only you'll have your programs. It should be in PDF. Each page should be numbered, okay, each page should be numbered, and you should submit it along with the declaration. So you'll have to submit lab file also, and I'll also see your execution. I will take your viva. That will be your lab exam for 30 marks on Tuesday, Wednesday, theory exam. So if you have no doubts, you may leave the classroom. If you have any, you may post your queries.